Okay, I think that maybe we can start now. I'm just going to make a short introduction about the webinar on the Cork Smart Gateway. So good morning, everybody. And this is Vanessa Pulgarin. I coordinate the Cork Smart Gateway initiative. This is an initiative developed by Cork City Council, Cork County Council, University College Cork, the Nimbus Research Center through MTU, and Tyndall National Institute. The Cork Smart Gateway is an initiative that actually puts in place Cork as a smart region. So we look for technology to enable projects that would enhance the lives of citizens and to look forward to invest, study, and visit Cork. In this sense, we have the webinar series Innovating Through Technology, and we've had webinars since October last year on different type of technologies and how these technologies can be applied in different type of businesses. Technologies such as AI, augmented reality, virtual reality, and in this occasion, we have the technology IoT, the Internet of Things. I'm going to introduce to Kian Murhu now. He is going to be our moderator. He's the European project manager at Tyndall National Institute. He has won over 7 million of competitive funding through European projects. He has broad experience on H2020 projects and now also Horizon Europe, that is the new program. And he has participated in European Commission networking, consultation groups as well to create technology roadmaps. So having nothing further ado, Kian, the floor is yours. Thank you very much, everyone, for joining us.
Thanks, Vanessa. Good morning, everybody. Welcome to the Cork Smart Gateway webinar on making better business decisions through IoT. So today we've got 5 speakers. We've got Mike Hayes from Tyndall National Institute, Professor Dirk Pesch from the School of Computer Science in UCC, David Moore from Viska Systems, Fiona Edwards from ApisProtect, and Brian Cahill from the Nimbus Research Center. So we'll have time for some questions at the end of the talks, but we'll kick off first with Mike Hayes. Mike is the head of group at the Tyndall National Institute and the representative in the Cork Smart Gateway. He's an internationally recognized thought and technology leader in developing solutions to power the Internet of Things, eliminating the need for battery replacement and making the world more energy efficient and sustainable. He's also at the forefront of building international collaborations between all the stakeholders involved to guide and accelerate the adoption of this technology. And Mike is going to talk about Internet of Things opportunities today. So take it away, Mike. Mike?
Okay, thanks for that, Cian. Can you hear me now?
Yeah.
Yeah, okay, very good. All right. Okay, so good morning, everybody, and thanks for this opportunity to present to you this morning. As Cian said, I'm just going to talk very high-level presentation about the Internet of Things and what kind of opportunities does it bring for us. So a good place to start is just make sure that we're all on the same page in terms of Internet of Things. I've put the Wikipedia definition up there for everybody to read, but in very simple terms, it's about things that effectively talk to each other. They gather information, and then the information is analyzed, and it helps us create awareness or action, so we can, improve the operation of various types of devices and systems for various applications. And I'll share some examples of this in a few moments. Now, you will hear me talk about what I call an edge device. And this is my definition here of what an edge device is. It's some sort of a device which finds a way to connect to the internet, for example, via a local area network or a wireless network, a router or a gateway. In simple terms, what we have here is a set of data that we need to get to the internet, and we need to find the most effective way to get that to the internet in a reliable mean, also minimizing the amount of power. And I'll explain the reason why power is important in a couple of minutes. So I describe these as kind of lifeboats that we are trying to simplify the process of getting that data to the internet so we can process it. And we can do all of the fancy stuff then, the visualization, the processing of the data, and the decision making, once we have a bigger engine available to us to do the processing and the decision making. And the big attraction here is that according to the analysts, we're going to have a 1 trillion sensor economy by the year 2025. So that's, 1,000 billion sensors. So that's a huge opportunity for all of us here. So maybe at a high level then explaining to you what it can do for us. So in terms of the energy and resource efficiency domain, We can use these wireless sensors for things like smart heating control systems. There's also a huge opportunity at the moment for us to embed these sensors, put them on, in, or near, or indeed inside various types of renewable energy systems, such as wind turbines, solar panels, embedded storage systems. So we can optimize and stabilize the integration of these renewable energy sources. These also have a significant home in our factories as well. So we can put these sensors again in and around equipment, so we can optimize the efficiency. We can optimize changeovers within the factories. We can identify bottlenecks. We can particularly help with the agility of these factories, which is going to become ever more important for Industry 4.0. And then also at a machine level, we can do things like predictive maintenance. We can embed these sensors and we can gather the information on these sensors to understand, are they operating efficiently and reliably, and is there a need to go and turn off the machine and do some predictive or preventative maintenance, minimize downtime, optimize uptime, optimize availability of machinery, and so on. In terms of implantables, this is another very important application vertical for us for these IoT devices. We can put these sensors indeed inside people or on people or around people, things like pacemakers, things like sports performance, so we can enhance we can get some feedback regarding, the ability of somebody to play a particular sport and what they can do to, for example, in areas such as tennis or golf, how people can improve their swing. Very important role in assisted living, giving people the opportunity to go back to their homes and to recuperate there, whilst having the assurance that the sensors can detect whether somebody has a fall or there's an issue with their mobility within the house, and giving that information back to the carers of that person. Also, the idea of smart bandages. If we put bandages on people, using sensors to determine, is the wound healing effectively? Is there a need for someone to return back to the clinic or the hospital? Can also be used for things like optimizing people for things like running, gait monitoring, as we show here, or for doing things like sports rehabilitation. And then, we've heard about, things like the Google Glasses a number of years ago. There is still an ongoing opportunity there for us to embed sensors into things like eyewear, so that we can gather information and help people with their safety, their security, their reliability, and then their overall experience in life. It also has a big opportunity for us as well in the whole area of smart mobility and safety. So, for example, putting tags, self-powered tags, on various types of packages, equipment, infrastructure, and so on, so we can detect at a given point in time where devices are. They are going to be increasingly important for first responders. So, for example, if somebody needs to get to an incident site, how do we get there as quickly as possible? How do we assure that the first responders are able to enter a building and leave it safely, identify the location of the person or the incident, and find our fastest way and safest route back to the hospital or whatever. And in general, for things like environmental monitoring in our smart cities, in our homes and so on, it's all about putting sensors on, in, or near people, equipment, and infrastructure. Now, a lot of the work that I do in Tyndall actually relates to the power source for these, which is a significant challenge. So the challenge is as follows, that for a typical application, and of course the applications vary quite significantly, typical battery life is around 2 years, whereas for most applications, we need something like a 10-year battery life. That means multiple battery replacements. This means downtime, it means maintenance, and it's actually the cost and the logistics associated with rather than the cost of the battery itself. It also means major environmental issues. I mean, I talked about the trillion sensor economy we're going to have by the year 2025. Do the maths on that, and that means that we're going to be manufacturing and disposing of 130 million batteries every single day, and that's just for IoT applications. Significant opportunity here to reduce the environmental impact if we can mitigate the replacement of these batteries. And as I said, this is a major focal area for us at the Tyndall National Institute, and hopefully at future webinars I'll get an opportunity to explain some of these initiatives. But at a high level, there are 3 ways really of making these batteries last longer. The obvious one is to try and make the batteries last longer. So we need better batteries that supply more energy in a smaller area. But it's not the only thing that we need to look at. We also need to look at the actual power consumption of the IoT devices themselves. What are the opportunities for us to minimize the power consumption of the device so that for a given battery size, it would last longer? And then finally, last by no means least, and this is a key part of the activities I'm involved in, is the concept of energy harvesting. I mean, we're all familiar with this, at the large scale, wind turbines, solar panels and so on. But at the MEMS level, at the small device level, there's big opportunities for us to take ambient energies, heat, vibrations, solar energy, and try and convert these to electricity and use these as an alternative source to extend the life of the batteries that we have. Just one last quick example to give you an idea as to where this can actually be used practically. So we were involved in an EU project called Composition with Boston Scientific and Clonmel. And the whole idea here was that they wanted us to improve the reliability of one of their machines. And in that machine, they have blowers or fans. And the idea was that we retrofitted sensors that effectively listen to these fans and could detect when the bearings would start to go in these fans. The upside of that is that every time we mitigate a failure for that, the saving to Boston Scientific is around 40,000 euros each time we do that. They're manufacturing pacemakers, so obviously the unit cost of the devices going through the machine at that time is going to be very, very high. Another application there we had was asset tracking. So very often in Boston Scientific, they need to gain access to inspection microscopes, test jigs, trays, containers, and so on. And putting some sort of a tag which has its own power source that will last a long time can be very important so they can quickly access this. The problem is if the battery dies, then it's no longer possible to communicate with the devices. So one important trick of the trade really is that at least if the battery is going to go, just keep a record of the last place that you've seen or detected the device. That's it. My 10 minutes are up. So thanks everybody for listening. I hope that's given you some food for thought. And I'm just going to leave one slide up once we transition to the next presentation. One of the unique things about Tyndall here is that we have what we call an ecosystem of principal investigators. So what I'm showing here is the concept of the battery that we're trying to replace. And as you can see here, we have a whole ecosystem of people developing materials, devices that do the generation, the storage, and the system integration of the various components, ICs, magnetics, and so on, into IoT systems. So hopefully at a future presentation, I can go into this in further detail and indeed talk about other types of technologies that are being developed within Tyndall. For example, the various types of sensors and transceivers and microcontrollers are being developed for these IoT devices. So, Sinead, folks, thanks for listening, and back to Cian.
Thanks, Mike. That was under 10 minutes. Great.
Very good.
So we'll leave the questions until the end. So just to let everybody know, if you do have any questions, if you can add them to the Q&A section at the bottom of the screen, and we can run through them at the end of all the presentations. So the next presenter is Professor Dirk Pesch from the School of Computer Science and IT in UCC. And Dirk is a professor in the School of Computer Science and Information Technology and director of the SFI Center for Research, Training and Advanced Networks for Sustainable Societies since 2019. His research focused on principles, technologies and applications of the IoT and cyber-physical systems. He's particularly interested in applications of those technologies to smart and connected communities, smart manufacturing, and the build environment. His experience also includes being a principal investigator at research centers such as Connect and Confirm, and he held the position of head of the Nimbus Research Center from 2009 to 2019. So Dirk's going to talk today about connecting the Internet of Things. So thanks, Dirk.
Thanks very much, Cian. So just following from Mike's sort of introduction on what the Internet of Things could do, one of the big issues is how do we connect individual devices. So you've heard about the Internet of Things, and Mike mentioned sort of connecting things to the Internet, measuring, sensing data on all sorts of things from machines to what we do in cities, for example. You might have heard that it's about smart appliances, smart applications, smart devices, etc. But the IoT, in fact, is a systems concept, and it stretches from the physical devices. Just let me get the laser pointer out there. So stretches from the physical devices that Mike mentioned, for example, and where Tyndall developed really innovative new technologies, to connecting these devices to sort of gateway edge computing systems, gathering data, and really where the value, much of the value is in the applications and the business intelligence we can get from it. So one of the things I'd like to focus on in this talk is the connectivity aspects. And there's a lot of things, a lot of buzzwords that are flying around, and you might have wondered, you know, what does this mean? What does this offer us, etc. So if we look at, in particular, wireless connectivity, but I'll talk a little bit about wired connectivity as well, is then this is often associated with a term called machine-to-machine communication, and you might have heard about this. So how do we connect these machines, these things to each other? And the connectivity solutions are like a zoo. You know, this is just sort of an example, and I've put up logos of things that you might have heard. And this is just a subset of it. I mean, I could talk for hours on what kind of connectivity solutions are out there. But if we want to characterize those connectivity solutions, then what is important here is to understand what's the kind of range that they can cover. That's both for wireless as well as wired solutions. What kind of throughput or data rate do they offer? Because you know, if we want to transmit video, for example, on video analytics in cities, or I think one of the speakers, following speakers, will talk about some of their application on using video in industrial environments, for example. Power consumption is a huge issue, and Mike elaborated very well on this, because if we want to transmit over a longer range, we need more power, for example. Or if we want to transmit higher data rate, we need more power. So we have to understand what's our application and what does that mean from a power consumption. So a lot of these different technologies, and here I'm focusing largely on connectivity technologies that are standardized. So where there are global standards and where you have a range of manufacturers that you can buy, for example, chipsets and solutions from to integrate into your IoT applications. So here I'm looking at two dimensions: the radio range, how far can they transmit, and the data rate, for example. And I'll give some examples. So there is the sort of at the quarter one here, the lower end, there's connectivity solutions based on a standard called IEEE 802.15.4, and you might have heard some of the names associated with it. So Zigbee, for example, Thread, is Wysoon. These are technologies that are based on this. In the industrial space, wireless HART, for example, you might have heard about those. Bluetooth, I'm sure everybody knows about Bluetooth, which is probably the connectivity solution in the IoT space with the most use. And then there is Wi-Fi, for example, and you know, everybody uses Wi-Fi really to connect to the internet. But of course, Wi-Fi can not only connect our laptops and desktop computers to the internet, but also a lot of machines. And so that's another use. But what's then really interesting also is something that has emerged more recently are two types of technologies that transmit over wider, longer range. So there's one called low power wide area networks. And you might have heard about things like Sigfox, for example, which is a solution. And there's a network in Ireland that's operated by a company called VT Networks. There are other technologies like LoRa, for example, that you might have heard about. And there are a number of networks that operate in Ireland. For example, there's the Pervasive Nation LoRa network that's operated by the SFI Connect Center, and where I'm involved in, and we've done a lot of work around this technology. For example, there's a new company called Cellnex that has plans of rolling out a LoRa network in Ireland, for example. And then there is the 4G and 5G based wireless that you might have heard about. And one of the big differences, distinguishing factors between sort of this class of low power wide area networks like Sigfox and LoRa, for example, and there's others like -7, IoT, and I don't want to elaborate on those because they are a little bit more fringe and you mightn't have heard about them, compared to 4G, 5G based wireless, is that the frequencies on which the LoRa and Sigfox transmit, these are so-called unlicensed spectrum. These are frequencies where everybody can transmit. So LoRa is a connectivity solution that everybody can use, and everybody can build their own network. So for example, I teach a module in our master's in computing science on IoT. And in the lab, we're using LoRa with the students, for example. So just after this webinar this morning, I will have a lab where the students connect the devices that they have to what is called the Things network. This is an open public, now probably globally operating network where you could build your own IoT solutions and you can use the network without having to pay for it, for example. Now, if you wanted to business of a business on it, then there are support solutions that the Things network have, for example, which cost some money. But just for experimenting and trying it out, it is actually completely free. Whereas 4G and 5G technology, and we know 4G, we know things like LTE, for example, and so on, because our mobile phones use that technology. But 4G like LTE, for example, has also IoT solutions, and this is called NB-IoT, narrowband IoT, which is a solution in Ireland offered by Vodafone, for example, which can connect IoT devices. It's a much lower power version of 4G, so your smartphones need recharging every day. Maybe if you have one that really works very well, maybe only every 2 days. But it's a far cry from the years that Mike spoke about. And so what we are interested in here is, in this particular thing is how do we reduce the power here? And so NB-IoT is that solution, but it is offered by a mobile network operator. So it requires spectrum that's licensed. So the Vodafone have paid a lot of money for it. And it's a solution where you have to pay money for, but it is based on an operator, and so you get the same kind of quality of service reliability that you might expect when you use your smartphone, for example. So if we look at some of the use cases, and Mike already mentioned them, where would we use these wireless technologies? So for example, Bluetooth and another one called AND is used in wearable. So Bluetooth is something that you might have a smart watch that connects to your smartphone via Bluetooth. So these are technologies, connectivity solutions that are very popular there and very suitable to this. If we look at the smart home, for example, some of you might have smart home technology like lighting appliances you can turn on and off from your smartphone, for example. Here there are Wi-Fi solutions, for example, so light bulbs with Wi-Fi built in, or Bluetooth is another one. And then there is other technologies called Zigbee and Z-Wave, which are used in the home environment. And these ones are all short range, sort of low data rate solutions. And because they're so short range and low data rate, they have very long battery lifetimes. So a lot of those can support devices that are battery powered and can basically be active for years. There's also power line communication, KNX. These are wired IoT solutions that, and those ones don't have as much power problems because they're wired, but they are less flexible, of course. And then if you look at IoT in buildings, for smart buildings, for example, again, we have similar solutions here. Wi-Fi, Bluetooth, Zigbee is used, but another one called Enocean. And Enocean was one of the first commercial self-powered IoT solutions. So using technology that Mike was talking about earlier in terms of energy harvesting. And again, we have lots of wired solutions here as well, but again, they don't have these power problems because they are wired and they can transfer power, electricity over the wire, apart from communication. Manufacturing here, there are solutions that has been out there for a while called Wireless Heart, IO-Link, for example. These are wireless solutions based also on short range, low data rate. But then you might have heard, 5G, everybody talks about 5G, and there is a huge expectation that 5G and also NB-IoT will be a big game changer in IoT and manufacturing. And so we'll have to see this. And we are working currently with Johnson & Johnson on a project to evaluate IoT evaluate 5G-based IoT in manufacturing. So we're collaborating there with Johnson & Johnson in Cork and Limerick as part of my involvement in the Confirmed Center. And again, there's other solutions, wired solutions, for example, that exist just for completeness. And then you might have heard about the smart grid, so smart utilities, water metering, etc. And here, again, we find wide area technologies that cover a longer range, because we now need to cover potentially a whole country. And so again, technologies I've already mentioned, like NB-IoT from Vodafone, would be used here. GSM, in fact, old mobile telephony technology is in fact being used here. So Cork County Council, for example, connect a number of independent water schemes, for example, via GSM for monitoring. Sigfox LoRa are big technologies here that are used. Wysoon is another one that is heavily promoted by chip manufacturers like Texas Instruments, for example. And then finally, in smart cities, again, we have similar technologies here. So for outdoor applications and so on, the longer range connectivity solutions are preferred. And here we need to trade off between data rate and range. And then in indoor environments, we have typically the shorter range technologies. So that's it from me. And I look forward to your questions. Thank you very much.
Thanks a lot, Dirk. That's interesting. So next up is David Moore from Viska Systems. Dr. David Moore is the CEO of Viska, a company founded in 2015 that specializes in three main areas: machine vision, robotics, and custom software. Today, Viska is marketed as a company creating intelligent automation that enables machines to move, think, and see. Viska has grown to become a market leader in the deployment of automated inspection solutions, in particular of AI-based machine vision, inspecting millions of products annually on manufacturing lines in the medical device, automotive, electronics, and food and beverage industries. David graduated with the first class honors in engineering in computer-aided mechanical and manufacturing engineering in 2008, and later went on to pursue a PhD in the area of laser, micromachining, and high accuracy surface metrology in the evaluation and improvement of solar cell performance. And David's going to talk to you today about leveraging IoT and AI for automated robotic inspection in manufacturing.
Good morning, everyone. Second, I just go full screen here. There we go. Good morning, everyone, and thanks for the nice introduction there. So today I'm going to talk to you a little bit about how we've used in one of our applications, using one of our products, IoT, to benefit our customers in real world applications for robotic vision inspection, mostly in the manufacturing context of manufacturing lines for multinationals. So the title of the presentation, leveraging IoT for AI for automatic robotic inspection. I've already had a very nice introduction. Thank you very much, Keen. So that's enough about me, but my main three areas of interest are machine vision, deep learning AI for machine vision, and also then robotics and motion control. So today I'm just going to talk a little bit about Viska just for a couple of minutes. I'll talk about some of the automation trends that we've seen and changes, and I suppose how IoT is becoming even more and more to the forefront constantly the whole time. I'll talk a little bit about our product and how that integrates with IoT, a little bit about how that works in the background, and then just finish up with some, I suppose, a conclusion of how that benefits our customer at the end and how they've seen the benefit out of IoT. So our company works in those three main areas. It's machine vision, robotics, and software development, mostly which we do LabVIEW. And we market that as we create intelligent automation that can help machines to move, think, and see. And I suppose this ties in with automation trends. So I suppose over the last years since we started up, we kind of spotted this trend of increased machine vision, increased in robotics, and then the IoT to bring it together. And it suited our skill set very well. So in order to proliferate that a bit more, we partnered with some very strong industry partners. So we're preferred system integrators for Cognex, which would be the world's leading machine vision brand. We're official integrators and consultants for National Instruments. So we do a lot of LabVIEW. And then on the motion control side, we also work very closely with some robotic suppliers, so be official integrators for the likes of Mechademic, which is the robot you see behind me here, just on the table this morning. And one of the trends that we see is like all of these are very high growth areas where we work is just at that intersection. And that kind of segues into the next part, which is just a little bit about our product. So one of the things that we spotted in the market a couple of years ago is that it was really difficult to set up robots with cameras to do inspections on various assemblies. And this was really a pain point for a lot of customers we were talking to. So we went away and we developed a no-code solution called Visible, which is a software platform where technically we can support any type of robot with a custom camera head, and then we can automate vision inspections using really the latest cutting edge technology like deep learning and AI. So at the moment, we support two types of robots. We support this mecha, we support cobots like the Universal Robots E-Series. On the right of this slide, then you see that we have our camera head, custom camera head. So this comes in different flavors and resolutions and types of camera. And then we interface that with CogNexVidi as our AI library that runs, integrates with Visible. We also have the ability with our new release coming out of Visible version 2 to integrate a custom driver. So we have customers who would like to do vision inspection, but would also like to do a test with another type of instrument, such as a gas analyzer or electrical probes. And we can write custom drivers to interface that. So it really becomes a very flexible platform to integrate whatever the customer needs to make it work. If you think about robotic inspection, or pretty much anything you do with a robot, is you want to command a robot to move from one place to another place. So point A to point B, and then do something when it gets to point B. And that's what our no-code solution here provides in Visible. So we have the ability to add inspection points. If you're using a cobot, you can manually by hand move the robot into position and you see a live view of what the camera sees. You can optimize all of the image parameters, and then you can set up your image processing to do automatic inspection of the part or assembly. So we, on the right of this slide, you see we have an inspection plan. An inspection plan contains inspection points, and each inspection point then contains information like robot position, the camera acquisition parameters, and the image processing data. And this will tie into the IoT later and how we've integrated everything together. The next part then of Visible is our workflow mode. And this is where we can integrate back into IoT or just into factory level. So we can add different actions that we want to perform along the step of using this bit of software. So we can get dialog boxes for operators to enter part numbers, or we can connect back to factory servers. We can connect to OPC UA servers in the factory. And that way we can connect to get data into Visible, but we can also get all of the results data out of Visible and use that data somewhere. So at the moment, we have the capability to connect, as I said, over OPC UA, and we can wait for triggers to command us to start an inspection, and then we can export the data. Typically, that's like XML or JSON in format. And we can also save all of the image data. So I have an example here of what it looks like when it's running. So I'll just play this very short video. So you see the robot comes down here, takes a couple of images, and it does the inspection in parallel in the background. So you can see on the left of the screen, it's all green. So it has passed all of those inspections. So that's just basically how it runs to the user when they see it, when it's up and running and is already configured in their factory. So it's very hands-off. How did we integrate then this with IoT? So if you look at step number 1 down below here, we have a customer part or assembly. So this could be anything from a small part that is kind of handheld size up to like massive engines and those kind of components. And we want to do different inspections. So we want to check our parts in position. Are they present or absent? We want to maybe check the quality. So you could have, say, is a part polished or not polished? Does it have defects? We can also do things like read difficult to read text. So sometimes you on a casting, say for example, on an engine block, you might have a number or a part number, and we might want to read that with the camera in order to trigger something else in the inspection. So the customer would come along, the operator would look at the part assembly. They might have some paperwork, or they might have an RFID tag. They're able to scan that into their MES or ERP system, whatever they're using for their production control. And typically within factories of of the kind of multinational scale that we were normally supplying this into, they would have an OPC UA server, typically something like a Kepware server available. So they can update tags that are running on the Kepware server, and we can set visible to wait for those tags. So the data coming in could be, for example, a part number and a start trigger. So the operator has started the process through the MES system. The robot comes down, does its inspection around the whole assembly. And then while it's recording all of that, it's saving all of the images onto a file server somewhere in the network. And then at the end of the inspection, it sends up all of the results data. And I have a small example of what that kind of results data might look like later on. But for example, we could be coming down using the part number to define the inspection plan that is run. And then we might read the serial number off the unit itself. We might check all of the different inspection points and report the results for each of those back up. And they can get saved to a database. And then typically the customer will get a custom dashboard made that will allow them to search all of their products that have been made by the serial number, and they can see all of the inspection points and all of the results for every single part of their assembly. So this gives them a completely new level of detail of what they would normally have in terms of their quality and the different quality gates they have along their manufacturing line. So the main benefits in ROI that our customers see, one is this idea of digital records. They have full traceability, but they can also use that then to drive continuous improvement. So for example, if a lot of the time you might have quality operators on the line, and we see this a bit, they would find something small is wrong and they would just fix it, but they would never record that that's a problem. So by having digital records, you can actually get better eyes on what happens in the manufacturing line and use that to drive continuous improvement. And that's very important for moving towards higher levels of automation. So the inspection consistency can be higher as well. Robots don't get tired on a Friday evening. You know, so and we have done studies with that where we found that especially for marginal defects, so things that are kind of a pass, kind of a fail, those ones in the middle somewhere, those type of situations, we found differences between human operators to be up to 40%. They can disagree quite a lot. So we can drive better consistency with this type of technology. We also then drive opportunities for headcount redeployment, and that's the next slide. I'll explain a little bit more about that. And then also we have opportunities for improved safety. So ergonomic things, you know, if you have a large assembly and someone is moving around it all day, that can be a little bit straining. So we can improve those things for the operators. The current setup sometimes for especially critical inspections is that you might have two quality operators involved in a particular quality gate. So one would check it if they were to find something wrong, they would call the second quality operator who would verify, you know, confirm or deny what they found as an inspection task. By implementing this type of solution with the IoT integration, we can actually push quality gates further upstream. So we now have more quality gates along the line, and we can get better definition of where quality problems happen with the same number of headcounts. So it's really like an assistive technology. We find rather than a human replacement. There's just too much variation and too many different situations you can have in the factory to completely remove the human, particularly in factories where you would have, let's say, lower volume, high variation type manufacturing happening. So the benefit then of IoT integration is digital records. So you have a record of each point on an assembly or every area of a part. You have consistent automated inspections, and you have timestamp information, and you have the recorded image information to match that you can go back, look at and verify as well. As I said, you can use that then to drive continuous improvement in the whole process. For customers we've already supplied this to, the vast majority get a return on investment in less than 4 months. So normally anything less than 2 or 3 years is a go-do project. So this is really something that makes a lot of sense for customers to do if they have some quality issues they need to address. And then just on the right of the slide, you'll see an example dashboard that a customer might have. So, you know, they would get a dashboard, usually web-based. So they'll be accessing this through their browser. They can go along, search by a serial number, and they'll get a list of all the inspection points. They could click on any inspection point, and then they will get a picture of the image, and then the kind of pass-fail result and inspection point name. So that gives them a lot of power to be able to drive improvements based on the IoT connectivity. Unfortunately today, I don't have time to stick around for the whole Q&A. So if anyone does have any questions, please visit our website at viska.ie or info@viska.ie will get to me. And yeah, please do inquire if you have any questions. I'd be happy to try and help. I'd just like to conclude then just by saying thanks a lot to Cork Smart Gateway for the invite this morning to present. It's been a great opportunity, so thanks.
Thanks very much, David. It was an interesting talk. So next up is Dr. Fiona Edwards-Murphy from ApisProtect. So Dr. Fiona Murphy is CEO and co-founder of ApisProtect. She is among the most widely published authors on IoT and honeybees. She completed her PhD with the School of Engineering and the School of Biological, Earth and Environmental Sciences at UCC in the area of IoT applications for honeybee health, and is a graduate of the Bachelor of Electrical and Electronic Engineering BE Honours at UCC. Her company, ApisProtect, was recently listed as one of the European startups to watch in 2021 and also listed on the top 50 Irish startups to watch in 2021 by Think Business. Additionally, Fiona has been recently included in Forbes' prestigious 30 Under 30 Europe list, manufacturing and industry category, and has won many national and international awards, including the Rising Star Award at the Dublin Tech Summit, Women in Technology Awards, and the Women Mean Business Sodexo Newcomer of the Award 2018. And Fiona is going to talk today about the ApisProtect, Smart Beehives for the Future of Food. So over to you, Fiona.
Great, thanks, Cian. That was a great introduction. I feel like I have to live up to that introduction now. So thanks very much, everybody, for having me here today, and thanks to Cork Smart Gateway. So like Cian mentioned, I'm Fiona, and I'm the CEO and co-founder of ApisProtect. Where I came to, or where I came from to end up working in IoT applications for honeybees is, as Cian mentioned, I did my PhD at UCC between the Embedded Systems Group in engineering and the School of Biological, Earth and Environmental Sciences. It was an interdisciplinary PhD, an interesting area to go into. But basically, I had worked with the Embedded Systems Group during my undergrad. I'd done a couple of internships with them. Absolutely fell in love with the whole area of wireless sensor networks, and really what really made me love the whole area of what ended up becoming IoT was the whole using sensor data and using sensors, using the stuff that I was learning about in college to actually collect data that could have an impact on the real world. So I was looking for a really interesting application. I knew I wanted to do a PhD. I knew I wanted it to be really application driven, because that's really where what got me excited about wireless sensor networks. And that would have been in about 2012, 2013. And around the same time, I started learning about bees and beekeeping, and about all of the problems that beekeepers were having all over the globe. So at that stage, there we go. At that stage, there were an awful lot of news articles, headlines, publicity about a particular problem that was happening primarily in the US, but to a certain extent around the globe, called colony collapse disorder, which was basically this huge problem that they had in the US that was killing an awful lot of beehives. And it was really completely unexplained. It was completely unpredictable. Nobody really understood what was causing it. Basically, you'd arrive to your bees one day and you'd see that the majority of the bees had disappeared. Some of them would be dead, but with no really specific disease that they could detect or pest that they could detect that was causing this problem. And that's what sparked in my head. I was like, oh, well, that's a really interesting application for sensor technologies, because one of the biggest problems that these beekeepers had was that, this is happening tens, 20, even up to 100 miles away from them, and that it was, they were experiencing these problems, experiencing these losses, and they weren't able to watch what was happening all the time. And basically, it was kind of like, if we were able to do that, we probably would understand this problem an awful lot better. So I started working on my PhD in that area. Spent 4 years putting different sensors inside beehives, applying signal processing and machine learning techniques to try and understand that data and see if we could link what was going on inside the beehives to specific problems and specific situations within the beehive. And as part of that, I learned an awful lot about the beekeeping industry. So we learned a lot more about the problems that the beekeepers were having. So there were these problems like colony collapse disorder, particular pests and stuff like that get an awful lot of media attention, get a lot of people thinking. A lot of people in academia really focused on trying to understand and solve these problems. But what I learned from talking to beekeepers was really the majority of the problems and the majority of losses that beekeepers are experiencing are due to really, really straightforward problems. So beekeepers don't stay up at night worrying about colony collapse disorder. They're not up at night worrying about varroa mites or nosema or these other diseases that we like to talk about. They actually worry, oh, my beehives might be starving and I don't know about it. I could be queenless and I don't know about it. So that's when the queen bee is dead or missing from the beehive. They worry about the weather. If there's a storm, you know, they know probably some of their beehives have been knocked over and could be open and basically getting cold and the bees would be dying or leaving to find a new home. So they worry about really, really straightforward problems. And actually 77% of the losses that beekeepers experience are as a result of these really straightforward problems. And that's really the idea that sparked ApisProtect in myself and my co-founders' minds. So just after I finished my PhD in 2017, we decided to found ApisProtect. And our objective was to create a scalable solution for beekeepers. So there were technologies on the market at that stage. There were, you know, beehive technologies available. They were, you know, nice little, you know, I guess kind of like hobbyist technologies. There was lots of wires. They were clunky. They had big batteries. They could only communicate over Bluetooth. And, you know, beehives live out in the real world, up mountains and in farms, not with access to Bluetooth or Wi-Fi. So what we wanted to do was create a scalable solution. So a solution that could actually be deployed in a 10,000 hive operation, that can actually run in the real world. So an awful lot of the same thoughts that the previous speakers were talking about. So we set out to address the needs of a commercial beekeeper. And what we've developed over the last 4 years is our sensor technology. So I've got one of them here. So this is the device that goes inside the beehive. From that, we collect temperature, humidity, sound, and acceleration data. We then bring that data back to our servers and apply our machine learning techniques to process that data and turn it into useful information about what's happening inside the beehive. And that's really one of the really important things that we do. We don't expect beekeepers to interpret temperature graphs, interpret humidity graphs, try to interpret a sound graph, which, you know, even as someone who understands, you know, the mathematics and the science behind sound is very difficult to do when you're looking at a graph. It's very difficult to interpret. We actually process the information, give the beekeepers back useful insights into what's happening in their beehives. So they're able to log into the web platform and immediately know, okay, I need to visit this hive today because it's in trouble. I don't need to visit these other 10 hives, because at any given time, only about 20% of the hives in an operation actually need intervention. But until you get access to this data, you don't know what 20% of those hives are actually needing intervention. So you have to open every single beehive and try to find out what's going on. So one of the things that we had to do was collect an awful lot of data in order to train that machine learning. So we had it was a really exciting and fun validation period from 2018 until, I guess, late 2019, early 2020. We deployed 400 devices across the USA, Ireland, the UK, and South Africa. So what we were trying to do there was get a really representative sample of what beekeeping is like in different countries, because beekeeping varies dramatically. The conditions inside of the hive, the problems that beekeepers deal with vary dramatically depending on their conditions. So I've got some nice pictures here that show just how interesting that was. So here's from our deployment in South Africa in a wildlife reserve, where one of the biggest problems we had to deal with was baboons. So we had a base station, and it was, you know, trying to work out how to make sure that the baboons couldn't get at any wires, any connections, because they'll disassemble anything they can get their hands on. Here we've got a deployment in California. So there they had, you know, kind of similar conditions, but very different problems. Wildfires primarily, so you're kind of constantly keeping an eye on where are the wildfires and where are my beehives, and trying to make sure that you get in and move them before they get damaged, or smoke damage or fire damage. Then another deployment in Arizona. So again, that's a really, really hot climate. So we were used to being here in Ireland, where we worry in the winter about our beehives, about making sure that they stay warm enough. You never open them because they get too cold and the bees will die. In Arizona, it's the complete opposite problem. You never open your beehives during the summer, because the bees will have worked an awful lot to try and cool down the space inside of the beehive. The minute you open it, all of the hot air from outside will go in, and the bees could overheat and die. And then something a little bit closer to home, so that's the Peak District in the UK. So that's another really interesting mountainous, difficult to extract the data from deployment. And our final product that we developed, so again, one of the things that we put an awful lot of our engineering effort into was making our technology suitable for a real world beekeeping operation. Like, you know, earlier we were talking about batteries. Initially we had LiPo batteries inside our device. And then we had a bit of a think about that, about the real world of beekeeping, where a roof might be on the floor, your sensor might be on the floor and get driven over by a forklift. And what you don't want to do is have an exploding battery in the middle of this kind of somewhat dangerous environment. As well as that, often beehives can get diseases, and they have some very, very serious diseases where the response from the beekeeper will be to destroy not just the colony, but the entire beehive. So dig a hole, put the beehive inside that hole and set it on fire. Or they might want to bleach all of their equipment. So all of those things, they're very, very dangerous. So what we ended up doing was moving to a off-the-shelf battery. So now our device uses 4 AAA batteries. So they're a lot easier to dispose of, still a little bit dangerous, but at least they're kind of known levels of danger for the beekeeper themselves. As well as that, the realities of deploying a technology into an operation that's not used to dealing with technology. So our technology is installed on the roof, which obviously is what you take off. So if you're feeding the beehive, you're treating the beehive, you're working on your bees, you want to be able to take the roofs off and throw them in a pile in the corner, do your jobs on all your beehives. And when our sensor is on that roof and it's learning about this particular colony, we want to make sure that sensor ends up back on the colony it came from. So we came up with this labeling system, and we use a combination of colors, numbers, and shapes, because not everybody in a beekeeping operation necessarily speaks English. And we want to be able to make sure that it's very easy, that we're not slowing down their work, and they're able to understand, okay, I need to put the green roof back on the green beehive, I need to put the yellow roof back on the yellow beehive. And then another big challenge that we've had has been extracting the data. So like that, beehive operations are often, up in mountains, very, very rural deployments. So we now have actually 2 technology solutions, one for commercial operations that we primarily work with beekeepers in the US on. So they have very, very dense operations. They'll have 200 beehives in a single location. So for them, we actually have a LoRa base station, and our in-hive sensor has a LoRa connection. So we then extract all the data through one base station. And then compared to here in Ireland, where we've got our hobbyist technology that's on pre-order at the moment, and we're actually using narrowband IoT there, because you'll have maybe 5 hives in one location, and then it could be miles before you get to your next set of beehives. So for the much lower density solution. Then another thing, one more thing on creating an IoT solution for the real world is our console. So trying to compress an awful lot of information. We can tell an awful lot of things about the beehive, but trying to compress that back down to, here's the most important thing you want to know, beekeeper. So here we've got our hive by hive analysis. So we've got simple things like when the hive is lying on its side, that means our accelerometer thinks that the hive might be damaged, or after falling over even. And then, on our console, we try to compress a lot of our information into a single page. So we've got our alerts, low battery, your hive has moved, your hive has cooled too much. And then the results of our machine learning. So here, I think I took this yesterday from our experimental apiary, so I'm not sharing anyone's data. So in our experimental apiary as of last night, all of the beehives are alive, which is good. And 80% of them are growing and 20% of them are shrinking at the moment, which is, that's doing pretty well for this time of year in a beehive. So we're pretty happy. We know if we were a professional beekeeper, we would know we don't really have to go out to that yard right now. And that could save us, significant labor and material costs. And the key benefits that our beekeeper sees is they're able to manage their time and resources much more effectively. Like I just said there, they can check on their beehives remotely, so they don't have to drive hundreds of miles out to their operation to tell what's going on. They evaluate the condition of each colony in a much more in-depth way than they've been able to do previously, and remotely as well. And then identify, before they even need to go to the site, they're able to identify which colonies they're going to be working on. So they can do things like adjust the number of workers who are going out to the yard, what kind of equipment they're bringing with them. Are they bringing feed? Are they bringing treatment? And as a result, we see our beekeepers have better apiary management, increased production, whether that's honey or pollination. They've got fewer losses, and they've got better peace of mind about what's going on inside their operation. So that's everything I've got to say. I didn't talk an awful lot about the technology side. Feel free to ask any questions. I've been battered over the last 4 years as the CEO, originally being an engineer, to stop talking about the technology all the time. So I'd love to have a chat about that with anyone who wants to talk to me.
Thanks, Fiona.
Thanks.
Hopefully we'll get some questions at the end. So just a reminder to everybody to put your questions into Q&A, and we'll deal with them after the next speaker. And the next speaker is Brian Cahill from the Nimbus Research Centre. Brian currently works in Nimbus as a researcher, business development, and in project management capacity. Brian joined the Nimbus Centre in July 2013 as program manager for the Mallow Systems Innovation Centre. He first joined CIT, now MTU's, computing department staff in 2006, following 9 years working primarily in the telecoms industry. Since 2006, Brian has worked within the School of Engineering, UCC, on SFI and EU FP7 projects, while also lecturing in both undergrad and master's level civil and IT and AEC engineering students, with emphasis on software engineering, information modeling, and data analysis. Brian has also extensive experience with systems integration and project management. His research interests include wireless systems design, building information modeling, databases, and system engineering. He has published over 20 scientific papers. So over to you, Brian. Brian's going to talk about smart building, OPS, multi-building analysis and control towards an IoT solution for monitoring smart buildings.
Hello, everybody. I assume everyone can hear me okay. Yeah, that's great. And just looking at the participations list there today, and there's so many familiar names, and the expertise in the IoT space is actually quite good among a lot of the participants and the attendees, especially the attendees I'm familiar with. And I know that some of you who are listening to this webinar today have dipped your toes into the IoT technology space on so many occasions, trying to find the optimum solution. And it's probably a significant area because there's so many solutions. And it's quite a difficult area to find, let's say, the optimum fit, because that landscape and the technology is ever changing so fast. So today's talk that I'm going to give focus primarily on the energy theme, but I know Vanessa asked me just to focus on one project, but it's actually, I've taken bits from about 3 different projects Nimbus worked on over the years. Very much part of my agenda every day is the whole area of funding and trying to keep funding fed into some of these projects, and also assisting industry in particular with leveraging funding from various bodies to pursue some of these projects. And there's a lot of fantastic opportunities at the moment. And I know Keane, who's moderator today, is an expert in that space as well, actually, as is Mike, as is everybody. Today, we just want to take a little step back and just bring all these projects back to analyzing what is actually the baseline. What do we want to actually do to actually try and actually decide what is the optimum IoT solution for our product. Now, this particular picture you see in front of us is Gortine Agricultural College up in North Tipperary. Now, I suppose it's really fashionable to actually slap up a picture of a very commercialized farm, since it's such a fashionable area at the moment. But they have a lot of challenges where IoT solutions are frontline and center really in monitoring, let's say, the performance of a number of enterprises. So obviously the aerial view just shows us a whole pile of different sheds, but underneath the roofs of this particular farm is about 6 different enterprises. Each need to be monitored individually. Obviously there's an energy factor, there's a staffing factor, there's actually a stock breeding factor, maintenance, preventative maintenance factor. So, you know, it's a very complex issue to try and find what would be the optimum solution for this particular college in actually making and assisting them with the decisions they need to make all their enterprises sustainable and working as efficiently as possible. Another project that we actually worked on, I see some colleagues from Cork County Council attending here today. They would have been very successful in securing funding from the Interreg Northern Periphery and Arctic programme. We would have participated with them in deploying a solution called eLighthouse. Essentially, this is the deployment of some off-the-shelf sensors into the majority of the Cork County Council building stock. They would have had the challenge of trying to harvest, or harvest is probably the wrong word, but trying to gather as much energy data or as much, let's say, property characteristic data as possible from their building stock. It's a real, there's a real manual effort in the early days when we actually tried to establish the baseline of this project. So we would have went on an extensive research and development exercise with Cork County Council, and have defined and deployed a system now where they have access to most of their building stock at the moment, and it gives them an opportunity to actually dip in, see what bills are accruing in certain properties, and ability to add new sensors to that property, and ability to decommission sensors from various properties. So that'll just give you a sense of how, let's say, IoT is actually playing an important part and assisting Cork County Council in managing their building stock. The next slide, I know it's quite detailed and you probably can't view it, but you might be able to get a chance to look at this quite closer. It's probably the most valuable slide I have, actually. We're dealing with a company at the moment called iLandlord. It's a spin out from a property company in Dublin called West Cork Property Services, I think it is. And they have over maybe 150 properties across Dublin. And again, they have the same problem, like how do we manage these things, these properties? There's aspects of energy that we're not clear of, there's aspects of occupancy, etc., etc. So generally when we start a project in Nimbus, if there's a serious need to actually crystallize the challenge, we will deploy our user experience team. And on this occasion, one of my colleagues, Barry Gettings, would have been deployed to actually just meet as many stakeholders as possible, involved with the company, interview them, ask them about their experiences, what type of data they're seriously interested in monitoring, what type of actions do they carry out on a daily basis that could be actually maybe replaced by technology intervention, that kind of thing. So essentially, if there's anything to be learned from all the presentations today and summarize, I think it's actually Barry's approach of plan, do, check and act. It's probably something we've all learned over the years anyway, but in the planning section, I think he defines it nicely here in saying that in this particular project, we conduct the energy review and establish the baseline, energy performance indicators, objectives, targets, and action plan necessary to deliver results that will improve energy performance in accordance with the organization's energy policy for property management. Now, sometimes when we actually plan a project like this, there's a strong influence from, let's say, the quality standards or the operational experiences of the company we're dealing with. And that's all taken into account. And that's where it's so important for us to actually talk to as many stakeholders as possible within that company. For the Gurteen College project, we possibly interviewed maybe up to, I'd say, 15 staff. That really articulated a very clear picture of the type of system architecture that they need to actually deploy on that site. The do part is then implementing the energy action plan, educate and optimize. Okay, so you know, some of our colleagues today now talked about optimization, machine learning, that kind of stuff. So a lot of what we're doing at the moment in Nimbus in particular has a very strong machine learning element, data analytics element. I think everyone, I suppose, up to a number of years ago, was going through the honeymoon period of deploying, let's say, a piece of kit that actually gathered data. But like, what were we doing with the majority of that data? You know, that was a real serious problem. Now we have, you know, established models in data analytics that can actually do a lot of the work for us, and we don't really seriously need to bespoke much out there, to be honest. We have a lot of companies that come to us annually, and they want some form of data analytics bespoke model developed. Our team will actually, they hear the story all the time, and there's actually a lot of models out there pre-existing that can be reutilized for the need. Then just to conclude, let's say the two last elements of this approach in developing an optimum IoT infrastructure, there's a big focus on check, which is the visualization piece, the front end piece. And I think all of the speakers today talked about an element of visualization of data, especially in the area of bees, in robotics, and obviously a lot of what Mike talked about as well from Tyndall, and of course Dirk's overview of the frequency spectrum and the protocols. There's always a visualization element, and how does the stakeholder in these companies visualize the data or want the data visualized? Finally, then act. So essentially, we got a lot of data accumulated. How do we actuate on that data? So for a lot of the industry 4.0 stuff that we're looking at the moment, we're seeing a lot of what I've just discussed translating into an automatic actuation of a device or a decision among management. So that's a bit of a whirlwind tour, really, of 3 particular projects and an approach to actually developing a suitable architecture for your challenge. And that's really it, Keane.
Thank you very much, Brian. Very good. So I think we're just going to have a short 1-minute video on Enterprise Ireland innovation vouchers, and then we'll move to the questions. So the chat is still looking fairly bare. So if you have any questions, please add to the Q&A section. Thank you.
Yes, so thank you, Kian. I'm going to present just a short video as you said it about the innovation vouchers from Enterprise Ireland. But I would also like to remind all the attendees here, like the Cork Smart Gateway also foster the relationship between industry and academia. So if you'd like to get in touch with the University College Cork, Tyndall, or the Nimbus Research Center, we're happy to help in that sense. There's also a webinar uploaded in the Cork Smart Gateway website on funding the digitalization of SMEs, where European funding, where SFI funding in collaboration with industry, and where Enterprise Ireland also type of funding is well explained by our speakers. So just as a reminder that you can find more information there. And now I'm going to share the video.
As a business, there's one sure way to stay ahead, and that's to innovate, to explore new possibilities, to adapt to the challenges of today, to find a smarter way of doing things. It might seem intimidating. You might not know where to begin. It could be that you just need a little outside help. Innovation vouchers from Enterprise Ireland can help you tackle your innovation challenge. The vouchers give you €5,000 worth of time with an expert 3rd-level researcher to help you tease out your idea, develop a plan, or crack that business problem. They're easy to apply for and simple to use for any company, in any sector, anywhere in Ireland. Take your next step towards innovation. Visit innovationvouchers.ie.
Thank you very much.
So